characteristics of polynomial functions in factored form. Now, here's a sample question we want to take a look at. Use reasoning to draw a graph given the equation of a polynomial function. Sketch a possible graph of the function f at x equals x plus 2, x minus 1, x minus 3 squared. Here is the solution. Step number 1, determine the y-intercept. If you remember back to grade 11, to find the y-intercept, you let x be equal to 0. When we do that, we will substitute in 0 for the equation. Wherever we have the letter x, substitute the value 0. When we solve that, we get the value of 18. So we know that the y-intercept is at 18. The coordinate would be 0, 18. Now, determine the x-intercepts. Let f of x be equal to 0. F at 0 is equal to negative x plus 2, x minus 1, x minus 3 squared. We note that the last expression, x minus 3, or the last term, x minus 3, is squared. We would know from that then that the zeros, or the roots, would be x equal negative 2, x equal to 1, and x equal 3, and 3 is a double root. It will have a particular type of behavior at this x-intercept. Now, the next step is to plot these points on the graph paper. We know that x is negative 2, x is 1, x is 3, 3 is a double root. Now, let's plot these values. We need our graph paper, the x-axis, the y-axis, a reminder of what the values are. We will plot negative 2, 0, 1, 0, and 3, 0. We will plot the y-intercept at 0, 18. And now we need to determine the end behaviors of the function so we know which quadrants it begins in and it goes through to end. So the degree is even, the leading coefficient is negative, the graph will extend from the third quadrant to the fourth quadrant. So we know it goes from quadrant 3 to quadrant 4. It must pass through these points. So let's take a look at the possible sketch. We don't exactly know the maximum and minimum values, so we will just estimate these. Remember, this is a sketch, not an exact graph. So here is a possible graph. Now, notice the behavior at the 3, 0. It will come to the line and it will bounce back down. That's the function of a double root. And now, write an equation of a cubic function that has zeros at negative 2, 3, and 2 over 5. The function has a y-intercept of 6. Use the zeros of the functions to create factors for the correct family of polynomials. Since this function has 3 zeros and is cubic, the order of each function must be 0. Substitute these values into this equation as shown. So f at x is equal to a times x plus 2, x minus 3, and 5x minus 2. We get these values, of course, from the zeros. And now we need to find the value of a. So we need the y-intercept to solve for a, and we know that the y-intercept was given at 6. And we know that the x value at the y-intercept is 0, so we can substitute into the equation 0, 6. We will solve, and we will get that a is 1/2. So now we are ready to write the equation. The function is 1/2 x plus 2, x minus 3, 5x minus 2. You could, if you wish, use decimals to make sure that this is the correct graph. Sample problem number 3. Write the equation for the function shown in the image given. State the domain and the range of the function. And here is the image. Notice that at -2, the graph bounces, comes one direction and bounces back in the same direction, and it does that at 3. That's a clue to us that this is the graph of a double root twice. If we looked at the end behaviors, we would be able to determine the degree of the equation. So, first of all, we want to write the correct family of polynomials using the factors. The -2 is a double root, and the value of 3 is a double root. So we would write that in the form y equals, or f of x equals, a x plus 2 squared, x minus 3 squared. Now, what's our next step? To find the value of a. We were also given the clue of the coordinate 2, 4, so we can substitute that into the equation and find the value of a. And when we do that, we will notice that a 1/4. Now have our equation y equals 1/4 x plus 2 squared x minus 3 squared. Again, verify this using decimals to make sure that our calculations are in fact correct. Now, what is the domain? The set of all real numbers. What is the range? Y is an element of the real numbers, but y must be greater than or equal to 0. The graph is above the x-axis, so you cannot use any negative values. They must all be 0 or higher. Now, let's practice.